Hello and welcome! I'm Ethan K with Game Changer, and today I'm going to show you how to make a Pong game using Tynker. Let's get started. So as you can see, we have a blank project here. The first thing we're going to do is add our actors. So for the paddles, we're going to add 2 space platforms. And we're going to select a space platform, and we're going to add 2 of them, just like that. And these are going to act as our paddles. So I'm going to rename it to Paddle 1 and Paddle 2. And I'm also going to add a ball for our game. So now let's add some of our code. So the first thing we're going to do is the code for the AI. So when the ball is moving around, we want the AI paddle to kind of follow the ball, so that when, say, the ball is moving this way, then the AI paddle follows it and hits the ball back toward the player. So to do that, we're going to go to Paddle 1, and first thing we're going to do is drag in non-start. We're going to go to physics here. If you don't see physics, you can always go to more and add the physics library. But we're going to start physics, and we're going to set the shape of our paddle to rectangular. Next, we're going to go to motion, drag in this block called if on edge bounce. If the paddle is hitting the edge, we don't want it to go through the wall, we want it to bounce off the wall. And we're going to have it go to 0,350. That means it'll start in the middle of the screen at the top every time we start our game. We also want to set static to true. Set static to true. Our paddle is not going to be affected by gravity or any other type of physics. The only real object that's going to be affected by physics in our game is going to be the ball. Let's see what else. Let's set the rotation of our object to don't rotate. We don't want our paddle to rotate, we just want it to move back and forth. So we're going to set that to don't rotate. And to make the mechanism to have it follow the ball, we're going to forever glide. Under motion, should be a block called glide. Let's see, I'll search for it. There it is. Glide a certain number of seconds to an XY position. So this glide block is going to allow our paddle to follow the ball, and we want the paddle to eventually end up at the X position of the ball, and we want it to maintain its Y position. So to do that, we're going to go to sensing, and we're going to get this X position of mouse pointer block. And we're going to put that where it says X right here. And we're going to set glide 1 second to X position of blue ball. And we're going to see, it should be in motion. We're going to keep Y position the same by having it glide to its current Y position. And right here where it says glide 1 second, actually, here you can adjust the difficulty of your game. The larger you make this number, the longer it'll it'll take to follow the ball, meaning a slower paddle and easier to score on. So we're going to set this to 0.5 seconds, which is a pretty good difficulty. Again, lower would be harder. If you have glide 0.01 seconds, for example, it'll immediately jump to the ball's X position and forever follow it exactly. There's not going to be a lag, and therefore it'll be very difficult to score on. But we're going to leave it at 0.35 for now. Okay, so now let's work on our paddle movement. So to do so, let's go to paddle 2, which is our paddle. We're going to drag in the when up arrow pressed key, and we can change that to left arrow. So when the left arrow key is pressed, we're going to need a repeat while. Repeat while the left arrow key is pressed. Repeat while. And under sensing, repeat while the left arrow key is pressed. We're going to check if the position of the paddle is still on the screen. So if, and we can use an operator for that, if the X position is greater than the X position of the left edge of the screen. So if, let's see, if X position is greater than negative 390, and X position from motion here, if X position is greater than negative 390, then we'll have it move to the left. So then we'll have it change X by negative 10 pixels, and we're going to wait. I'm going to delay it by a tiny amount so that it doesn't immediately zoom over. It'll move a little bit slower. And let's copy that for the right arrow. So Control C, Control V. We can change this to right arrow. Repeat while the right arrow key is pressed. Change X by 10 pixels instead of negative 10. And if X position is, we actually want if X position is less than 390. So if X position is less than 390, then we'll have it move to the right. And let's add some more initial data to our paddle. So on start, we want it to do similar things to the AI paddle. So actually we can copy the code from the AI paddle. We don't want it to follow the ball because we're going to be controlling it instead. But we do want some of that initial data. So let's paste this in here. So let's see, what do we want from here? On start, we already started physics, so we don't need that. We do want the shape to be rectangular. We do want it to bounce off the edge. We want it to be at the bottom of the screen, so let's set the Y value to negative 350. We do want static to be true, and we don't want it to rotate, so that's all good. We don't want it to follow the ball. And that should be good for that part of the paddle there. Okay, so let's try testing our game. So when you click the play button, see how the AI moves to the where the ball is, the X coordinate of the ball. You should be able to move left and right. The block seems to get stuck, so we can actually widen the range that our paddle can go. So let's change this to negative 530, let's call it, and that works much better. The the paddle can go all the way to the edge, and 530 on this side, so that can go all the way to the right. So now let's look at the ball. So first let's set the ball up. So on start, we want the gravity on the ball to be 0. So let's set gravity to 0 by 0. We also want the ball to start in the middle of the screen. So under motion we can have the ball go to 0, 0, which will be right there in the middle of the screen. Also don't want the ball to rotate, so let's set the rotation style to don't rotate. And we can let's create a variable. We should have variables, this light pink color here. Let's create a variable for this actor only called speed. We want the speed to increase with every time it hits the paddle or the wall to make it a little bit more difficult as the game goes on. So let's set speed to 0 at the beginning, and we can constantly increase it as time goes on. Let's see, we want active to be set to true under physics. Drag in set active to false. We want that to be true so that it can interact with the paddles. Let's also set the size to 18%. I played around with this value. This seems to be a pretty good size for the ball. You don't want the ball to be too big or too small. 18%. You want it to start facing upward so that it can go towards the enemy paddle to start. So let's set the direction of the paddle. Set angle to 0 degrees. I'll just make it point straight up. Wait 3 seconds, and then we're going to send it on its way. So let's wait 3 seconds, and in physics we can set a linear velocity. Set linear velocity to 15. And we can, at this point, try out our game here. Let's see. Let's actually set this angle to 90 degrees. I'm sorry, that's straight up. 0 degrees is facing to the right. And it'll go straight up like we want it to. We don't want it to decrease its speed like that when it hits the paddle. So we'll fix that in a minute here, but it is looking a little bit more like a game should, where we're able to move back and forth. And probably most important chunk of code here, so bear with me here. We're going to create the actual functionality of our game. So let's go to physics, and we want the block called when actor collides. Now there's a bunch of different collisions that can happen here. The ball can collide with the wall, it could collide with the top or bottom, which means that the game will end, or it can collide with the paddle. And we want it to do slightly different things when it collides with each of these different objects. So first, let's deal with if it collides with the wall. We just want it to continue bouncing. We don't want it to necessarily do anything else. But if we have it hit the paddle, so let's drag in an if statement here. If it hits the paddle, if, and back to physics, if it collided with paddle 1, then we're going to have it do something. Otherwise, and we're actually going to need a bunch of if statements, so let's just drag in a few of these here for the multiple conditions. And actually, yeah, why don't we set that up now? So if it collides with the top paddle 1, then we want it to send it back down somewhere. If it collides with paddle 2, which is our paddle, if collided with paddle 2, then we want to send it back up. But if it's colliding with the top or bottom edge, then we want the game to stop, right? Because that means that one of the players actually won. So if collided with the top edge, or if it's collided with the bottom edge, then we're going to want the game to stop. So let's code each of those instances. If it's colliding with the top paddle, we want it to point in a direction back down. So let's get a point in direction, and we can actually grab one for each of these. Point in direction, and we kind of want a randomized direction, so it's not just going back and forth and back and forth. So bear with me here for this mathy portion here, but let's go to operators, and just follow along with what I'm doing, and I'll explain it in a bit. Point in direction, pick random 1 to 10 plus 180. And we actually want that to be negative 45 to 45. It's 180 degrees. And what that's going to do is when it hits anywhere on the paddle, it's going to choose any direction in this sort of triangle here, and it'll send the ball back down, and that'll add a little bit of unpredictability to the ball. And we're going to do actually a similar thing when it hits our paddle. We can copy that block of code and paste it into this other one. But this time we want it to be just pick random negative 45 to 45. We don't need the plus 180. This will send the ball upward in a direction between negative 45 and 45 degrees. And then of course we want to send the ball on its way, give it some speed. We can just search set linear velocity again. We'll set that to, actually, since we want it to be increasing speed, we'll set it to 15 plus our variable speed. But when we have the actor collide, we can increase the speed by 1 so that it'll constantly speed up. And here we can set the linear velocity for both of these to speed plus 15. And as the actor collides more and more, speed will increase, and it'll be 15 plus 1, 15 plus 2, 15 plus 3. And speed will continue to go up until the end of the game. So we'll just do that. And then when the ball is colliding with the top or bottom edge, we want the game to stop. So in control, we can just stop all. And now let's test out our game. There we go. It should be going back and forth there. The game is a little bit laggy here, but it should continue to to go back and forth there. And when it hits the bottom edge, the game will stop. It should do the same when it hits the top edge as well. Just a couple quick things. It seemed to me like the paddles were a little bit too big, so I can make them both a little bit smaller here. You can do this with code as well. Set the paddles to a certain size. Here, why don't we do that? In paddle 1 and paddle 2, we can set size to, let's just say, 60%. And same here. There we go. And that's our game. Remember to save it as well. I'm just going to call it Pong and save. I hope you enjoyed this tutorial, and I'll see you next time.